4 points of concurrency. Somebody tell me one of them. What? I mean, the orthocenter. Okay, let's start with the orthocenter. That is the points of concurrency when you connect all 3 what? Altitudes. Is Abney the only person that knew that? Hi, put your head down, please. Thank you. And then come get some papers after you put your phone up. Okay, point of concurrency of all 3 altitudes. So in order to do this, we have to know what an altitude is. What's an altitude? Here's one thing. We're talking about this quiz right now. All right, Maggie, what's an altitude?
The perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side.
Okay, so it's perpendicular. From, yes, has to make a right angle. From vertex to the opposite side. So this has to contain a vertex, and this has to contain 90 degrees. In my little triangle over here, I will draw an altitude. Contains a vertex, connects to the opposite side, makes 90 degrees. Does that say anything at all about midpoint? No. Altitudes start at a vertex, make 90 degrees at the opposite side. So when you are doing those coordinate ones by hand, the vertex is easy. But where do you know, how do you know where to connect it to the opposite side? How do we draw that when you're doing the coordinate ones like on the quiz? Ryan, what do I need to do? Opposite reciprocal slope of each side. So we need to find opposite reciprocal slope of the side and start making points from the opposite vertex. That's the orthocenter. Let's start a second one. This time we're going to talk about the circumcenter. The circumcenter. The circumcenter is the point of concurrency where all 3 what meet? It is not the medians.
Well, it's sexual.
Yeah.
Perpendicular.
Yes. So for me, when I have to memorize things, I try to figure out ways to help myself memorize it. And when I think of circumcenter, it's the one that's like really long. It has, I don't know, to me it kind of sounds like perpendicular bisector. Circumcenter, perpendicular, I don't know. They kind of sound alike a teeny bit. Circumcenter, perpendicular bisectors is like the really long name, and perpendicular bisectors is the really long name too. We need to remember this. A lot of people did this on the quiz, but you used medians. If you use medians, obviously it's totally wrong. Okay, so this is all three: perpendicular, bisectors. All three perpendicular bisectors. And then we need to know what a perpendicular bisector is. What do we know about a perpendicular bisector? Denise. Okay. But where? At the midpoint. So if we're doing this by graphing, we need to find what on the graph to be able to do this. What do we need to find? We need to find a midpoint. So up here, here's a midpoint. Okay, and once we have the midpoint, what else do we have to do? How do we make a line that is perpendicular and passes through that midpoint? What else information do we need? We need it to go like this. Matthew. I need this line to go through the midpoint and be perpendicular, but how do I make it perpendicular on a graph? Didn't you get some of these right on your quiz? Well, how'd you do? Did you get the circumcenter one correct? I don't remember if you did. One more page. Top of that page. Did you get the first one correct or not? Okay. John, can you tell me perpendicular bisector? I know it goes through the midpoint, but how do I make it 90 degrees? What information do I need? Now the altitude would connect through the opposite vertex. This doesn't necessarily do that. Every single time we did these, guys, what makes 90 degrees like on the coordinate plane? How do you make a perpendicular line on the coordinate plane? Perpendicular is what? Aaron? Opposite reciprocal of what? Of the slope of the side that the midpoint is on. We need to find the opposite reciprocal slope of whatever side that midpoint is on. So we have the midpoint of a side and use the opposite reciprocal slope of that side. This one does not have to pass through a vertex. Sometimes it will, but it does not have to pass through the vertex. So far I have talked about circumcenter and orthocenter. How are they similar? Why do we confuse these? How are they similar? Jay, can you tell me why both of these are similar? Yeah, both of them were finding perpendicular. So both of these were finding opposite reciprocal slope of a side. Now, how are they different? Rakaya, can you tell me how they're different? Right, this one has to go through the vertex, and what does circumcenter go through? Right, it's what we go through is different. So I'm just going to add that onto my little picture here. Vertex and midpoint. Okay. What's next? Or is that all of them? That's all of them? What's next? What's another one? Jesse, do you know another name? The centroid. I don't know. I think that's centroid is everybody's favorite. At least when you took your quiz, it seemed like everybody wanted to do centroid for every single question. So that must be your favorite. The centroid is all three what's? What did you say? We do have to find a midpoint, but what's the actual line called, Jesse? Medians. All three medians. And then what is a median? Which is vocab. Stuff is vocabulary on your vocab this week. Stephen, do you know what a median is? I know you've been gone for like a week. You know what a median is? What does median kind of just sound like to you, Stephen, who doesn't know this stuff because he's been gone for a week? Sounds like middle. Totally. Maggie, what does the median connect? So we are connecting the vertex to the midpoint of the opposite side. Okay, so for me, to help me remember centroid, it does sound like middle, center, centroid. Sounds like middle, and this is the medians. And median does sound like middle, so I'm thinking midpoint. So if I'm using the midpoint here, I know it's the midpoint because it's marked. We connect to the vertex. So we're connecting both vertex and midpoint in this one. So on the graph, what information do I need to find? When we have an ordered pair, what information do I need to find for median? Emily, if I have this on a graph, to be able to do this stuff, what information do I need to find? I'll give you a hint. The vertices, the vertex, will be given to you. So what do you still have to find on the graph? You have to find the midpoint. Do I need to find slope? I think there was like one person that didn't know how to find the midpoints also. I don't know if it was in this class. I think it's my other class, but just a real quick, actually I think they didn't know how to find slope. Maybe it was both. Anyway, real quick, the midpoint is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. You just average together the x's and the y's. Some of you can look at a graph and figure it out. Okay, so that's all you have to find for medians is the midpoint, and then you connect vertex to midpoint. Easy. How does that get confusing with maybe circumcenter? What do those have in common? Midpoint. What makes them different? One goes through the vertex, the other one perpendicular through the midpoint. How about centroid and orthocenter? How are they in common? Both go through the vertex. What do they have different? What'd you say, John? Orthocenter has to be perpendicular, and centroid has to go through the midpoint. These are different. But I see where they're easily confused because they have things in common. And then there's the one oddball that has nothing in common with the others. What's the other one? Anybody remember its name? I made it extra credit on the quiz. Center. Alex, what does the in-center connect? All three. You got your vocab sheet that's due tomorrow handy?
Yes.
Is it filled out?
Yeah.
Okay. Oh, I didn't put it on there. Do we have extra blanks on there? We better put the in-center down. While some people are grabbing their vocab sheets out, Matthew's going to tell me what's the in-center. I don't know. Yeah. Angle bisectors. Now, if you need your vocab sheet, we're adding in-center on it. What's the other one? Are there any others that aren't on there? Is in-center on there? Is not in-center and circumcenter. I thought I added those, but maybe it didn't print. Maybe I printed out an old one. I don't know. So all three angle bisectors is the in-center. And what's an angle bisector? Raylan, do you know what an angle bisector is? So it starts at the vertex, touches the angle. What's it do to the angle? Cuts it in half. That's what it does. Two completely congruent angles makes. So here it starts at the vertex. This one passes through and cuts the angles in half. Have we done this one on the coordinate plane yet with ordered pairs? Do you remember? Was there one on your quiz that you had to find the in-center on the coordinate plane? You have your quiz handy. Was there one that asked about in-center? Or were there only 3 on the quiz? Maggie? I have to take my back out. Well, read the directions. There were 3 graphs. Circumcenter, centroid, orthocenter. Right. We never did this one on the coordinate plane because you have to bisect an angle, and you can't easily, until you know more stuff called trigonometry, you can't easily find the angle on a coordinate plane. So this one you're not even going to have on the coordinate plane. You just need to know that it bisects all the angles. Okay? So use this as study material because we're having a test tomorrow. And this seems to be like the biggest we're struggling on when I graded it.